Let's discuss the test series 1 engineering mechanics, the question number 54 and 55, which are linked questions. Question 54 and 55. So let's first discuss the common data. So what is given is a smooth table is given, and you have two masses M1 and M2 which runs over a frictionless pulley and by means of a cable. Okay, so now what is asked in the problem is, if the tension is doubled, if the mass M2 is doubled, then what happens? The tension is increased by 1/2, then the ratio of M1 by M2 is asked. That is 55th bit. Now for the 54th bit, for the given configuration, what is the tension in the string? That is asked. Okay, so let me just draw the free body diagram, which is a basic step in any engineering mechanics problem. So let me just draw the free body diagram of M1 with all the forces that are acting on M1 due to all the other external means. So you have weight M1G, you have tension in the cable T. Okay, so this is FPD, which is free body diagram of M1. Now FPD of M2 will be basically, you have M2, you have the tension T, the cable like this, you have the normal force, and you have the M2G. So okay, and now this will have say because of the gravity, it will have the acceleration A. The mass M1 moves with acceleration A, so the mass M2 will also moves with the acceleration A. This can be understood from the fact that, say if I release this system, so M1, let's say it travels a distance x in time t, then M2 also will travel the distance x in time t, because the length of the cable is same. The cable doesn't lose or doesn't get stiff. The cable doesn't lose. That's the basic thing. So the length of the cable is same. So how much distance mass M1 travels, the same distance mass M2 travels for the length of the cable to be same. So when distances traveled in time t by M1 and M2 are same, their velocities and their acceleration at any point of time will be same. Okay, so let me take this as my direction. Okay, so now I'll apply the equation of motion, which is basically, if I take the vertical direction positive, sigma of My has to be M1A. So the downwards forces are positive, upward forces are negative, and this is the equation for mass M1. Now the action happens along the horizontal direction, so let me write down the equation in taking the leftward forces as positive. This is M2 basically. So T minus, there is no other force which acts rightward, the acceleration is this direction, which is M2A. So this is my 2, this is my 1. Now if I combine 1 and 2, I will basically get tension. So let me just eliminate T first to get A. You can just look at that A is M1 by M1 plus M2 from these two. And now if I substitute again, I'll get the tension, which is M2 into M1G by M1 plus M2, which is M1 M2 G by M1 plus M2. So this is what was asked in 54th. So the option is A. Answer is A. Now for the 55th, the mass M2 is doubled. So let the new mass be M2 dash, which is twice of M2, and the new tension be increased. The new tension is increased by 1/2. So the new tension is T dash. See, one catch point here is the tension and the mass relations will not change. Whether you increase the mass or decrease the tension, they will behave by this equation. So using this equation for the new scenario, where I have changed mass, so you will have M1, you have 2M2, and then M1 plus 2M2. So you have 2M1 M2. G is missing here. Okay, so now T dash is nothing but 3T by 2, and let me write down this one here. Now 3 by 2, and this tension is, I can use the old the 54th bit, the old relation. Okay, so now straight away m1 m2 cancels. So from this I can find out the relation between m1 and m2. So let me just simplify this. So what I get is it's m2, which is 2m1 plus 2m2, and this comes out to be there is, so here I'll be having 2m1 plus m2. There'll be 4 here, there's a 2 again here which is missing, so I'll have 4m1 plus 4m2 is, so this 3m1, let me take that side, which becomes m1, and here I get 2m2. So basically m1 by m2 is 2. So the answer is m1 by m2 is 2. Let's see the answer. The answer is D. So answer is D, A for the first bit. This completes our linked question. Thank you.